So now let's start discussing vector valued functions. So remember, a vector valued function is one that's of the form r of t, which you input in a t and it spits out a vector. So in general, you could also write this in component form. So it would look like this. And ideally what you think of these as doing is tracing out some kind of curve in space. And so now let's talk about, we took limits of these vector valued functions. Let's look at an example. So find the limit as t goes to 0, t squared I plus 3tj plus 1 minus cosine t over tk. Well, when you're taking a limit of a vector valued function, you just take the limit in each component. So I'm looking at the limit of t squared plus the limit I plus the limit of 3t j plus the limit of 1 minus cosine t over tk. Now in these first two I have polynomials, so I can just plug in 0 in place of t and I'll get 0i and 0j. But here if I plug in 0, I get 0 over 0, which means I need to use L'Hopital's rule to find this limit. So I'm going to use L'Hopital's rule. So this is equal to the limit as t goes to 0. Now take the derivative of the top. The derivative of 1 is 0. The derivative of minus cosine t is a negative sine t, so it becomes a positive sine t. The derivative of t is 1. So now you can plug in 0 in place of t, and sine of 0 is 0. So in this case, you just get the 0 vector back. All right, so then what did we do after we did limits? We talked about differentiation and integration. So let's look at some examples here. Find r prime of t for the vector valued function square root of ti plus 2 sine cubed tj plus 5t e to the tk. So for this first one, you just take the derivative in each slot, each component, do the power rule, 1/2 t to the negative 1/2. So put it in the denominator. You're going to have to use the chain rule here for this one. So it's going to be 6 sine squared t times cosine t. And then for this third one, you're going to have to use the product rule. So you'll get 5 e to the t plus 5t e to the t. Okay. And there's my derivative right there. All right. So now let's talk about integration. Let's look at one example. Find the indefinite integral. The integral of 4t cubed I plus 6tj minus 4 square root of t k. So again, you integrate in each piece. So if I integrate 4t cubed, you're going to get t to the 4th I. If I integrate 6t, you're going to get 3t squared. And then 4t square root of t, think of that as being 4t to the 1/2. So if I add 1 to the power, it would be t to the 3/2 plus c. And your constant c here is not just a scalar, it's a vector now. So let's look at another example involving integration. So let's find r of t that satisfies the initial conditions. R prime of t must be 4e to the 2ti plus 3e to the tj, where r of 0 is 2i. So to find r, we're going to integrate r prime. So you're going to integrate 4e to the 2ti plus 3e to the tj. So on the first one, you're going to do u substitution. You'll get 2e to the 2ti plus 3e to the tj plus c. So now we use our initial condition that we were given. When I plug in 0, well, if I plug in 0 here, you'll get 2i plus 3j plus c. But in the end, we were told that that's supposed to be equal to 2i. And then you're just going to solve for c. C is going to be negative 3j. So then, in total, r of t will be 2e to the 2ti plus 3e to the t minus 3j. All right, so then we talked about velocity and acceleration. So remember that velocity is the derivative of position. Acceleration is the derivative of velocity, so it's the second derivative of position. And then if you're asked for speed, it's the magnitude of velocity. So then after this, we started talking about tangent and normal vectors. So remember that your tangent vector, the formula for it is r prime of t over the magnitude of r prime of t. Our unit tangent vector. So let's look at this example. Find the unit tangent vector of r of t, which will be ti plus t squared j when t equals 1. So you're going to take the derivative of your vector valued function r. So the derivative of t is just 1. T squared, it's 2t. And then you want the magnitude. So it's the square root of 1 squared plus 2t squared It's the square root of 1 plus 4t squared. And so then your unit tangent vector t will be r prime over the magnitude. But we wanted to find this when t was 1. So plug in t equals 1. You'll get I plus 2j over the square root of 5. So this is 1 over the square root of 5i plus 2 over the square root of 5j. And there's our unit tangent vector.